Today's problem is to flat the given linked list. So this is the list that was given to us. It has right pointers and the down right pointers and the down pointers. What we need to do, we need to flatten this. We need to flatten this in a straight line like this. So if you observe that this is one list and this has a right pointer and this is one list. It has right pointer and this is one list. It has one right pointer and this is one list. If you observe the list, all the lists are sorted list. So as we solved merging the two sorted list, the same thing we need to apply here. But how we apply that is what the trick here. Mm, the algorithm that I'm gonna use it, I'll just traverse through the right pointer till the end. Once I get the place where there is no other right pointer, that will be the last list, and I'll merge that with the previous list. So the merging will happen for these two and return a sorted merge list, and that will become a third list. And after that, I'll merge that returned sorted list with this list, and this will in turn return the uh, merged sorted list of these three sorted lists, and then I'll sort finally with the first list. So it is very clear that we need to use the recursion to solve this problem. So I think I'm clear here. Uh, we'll start traversing through this till the end. I'm going here, and this I'm at the end, and there is no other right pointer here, so this would be the first list. And then I'll keep track of the previous list because I'm doing it in the recursion. In the recursion, the edge case would be returning this list. So the previous list will be there, and that will be 19, 22, 45, and 50. Now we need to have a separate method that is called merge list, which takes two lists, heads of two lists, and return the sorted merge list. So this particular method will return 19, 22, 28, 35, 40, 45, 50. This is the return of these two sorted list. Now we need to merge this list with 10 and 20, and the merging will in turn return 10, 19, 22, 28, 35, 40, 45, and 50. And now finally this should be merged with 5, 7, 8, and 20. Finally we'll get 5, 7. So as there is no space, I'm giving it the right pointer, but actually this is a down pointer. 8, 10, 19, 22, 19, 20, 22, 28, 30, 40, 45, and 50. This is the final list. So this is a simple algorithm, but the implementation is little tough because we need to use the recursion clearly, and uh, every time we return the merged list, we need to make sure that there is no right pointer at all. So first we need to make the right pointer to null and return that dummy list. So I'm gonna write code for it and it'll be more clear then. So that uh, list which is having the down pointer and right pointer will be given to us. We are assuming that, or otherwise we can make that list as well, but this is not part of the problem, so I'm not explaining that. But for now, we assume that we were given that list which is not flat. So uh, I'll write a method, and the node definition will be so it will contain a data and a down pointer and a right pointer. Down and right pointer. And whenever we instantiate this particular node, that means we are creating a node. So the constructor would be it will take the value and it just assign with the data, and the down pointer and right pointer will be instantiated to null. That is the first one. But we don't need this right now because this particular thing is like to create the actual the list which is not flat. But just to show the definition of the flat node, I wrote the code here. And coming back to this flattening the node, I'll just name that flat the node, and we will be given a non-flat node. I'm just naming that to represent that which is flat and which is not flat. Now, as we have discussed, we have nodes like this. We need to go till the end and come back, merge it, form one list, and come back, merge it, form one list, and come back, merge, and return that merge list. So it's simple. The edge case would be go as far as you can go towards the right where the right pointer is null. So the edge case would be if the flat nodes, that means non-flat nodes, right pointer is null, then just return that particular thing. Or otherwise what you will return, you will return the merge list. Merge list of, so here we are, and we need to catch hold of this. So this is the edge case. The edge case returns this, and we will be here. So these two. So merge list of non-flat node, comma, flat the node of non-flat node dot right. So this will just simple. It'll just finally return the uh, flattened list. The logic for merging the list is same as that of the merging of two sorted lists, but I'll again write the code. uh, the only thing that we need to do is we need to make that the merger lists, a final merger list, right pointer to null, so that we will not have any right and down pointers, only down pointer, that is a flat list. So how will be the merge list logic? We'll be sending the two lists. Those two lists are these, this one and this one. We need to catch them. So this is similar. We need to have some previous pointer to cut the links, and one dummy head to start with. That is also null. And the edge case would be while this p1 p2s are not nulls. Again, the comparison, how we compare these two, and then whatever is less, we need to make that initially the dummy head, and then start forming the links. Once it is done, then these two will be compared, and then if I suppose this is less, the link will be formed, and then this will be moved to here p2. Now these two will be compared. So likewise, the comparisons will happen. The same logic will write here. If p1 dot data is less than or equal to p2's data, first we will check, is this the first node? That means if this is the first node, the dummy head will be the null. So if it is null, then dummy head will be pointing to that p1. Or else we need to make a list. So we need to traverse the same thing, take some temporary node and point that to the dummy head, and traverse till the down, because we are trying to make the list flat, so only one direction. So till we go down, then we just make that p1, that is else logic, and we need to move the p1 pointer to the next pointer, that would be the down, and the link needs to be cut there, so the previous would be null. Previous is nothing but the p1. Okay, this is for this case. The same will be repeated, but in place of p1 we go to p2, and in place of p2 we make p1. So the else part would be like this. Same, we'll check for dummy head, is this the first node? We can do one thing, we can move the whole code into a separate method and just pass p1 or p2 based on the if conditions. If p1 is less than or equal to p2, we pass the p1 and make this particular code, this if else code, as one block. one block, and we just can pass p1 p2 pointers and replace them. You can do that as well. Dummy head and previous is becomes p2 now. The else condition would be the same. Let's have a temporary pointer and point, assign the dummy head to that, and traverse till you find the temp dot down is null. Once you find that, now you just assign temp dot down to p2, and previous will also be assigned to make to cut the link. So p2 will move to the next node and cut the link. Done. All done. Now what if only one list is exhausted and the other list will have a few more nodes? So we need to handle that case as well. So if p2 is not equal to null, then we are keeping track of the last nodes as previous. So previous dot down equal to p2. We are just linking the last part. Else if p1 is not equal to null, then previous dot down will be linked to the p1. Done. So the only extra part here is we need to, so now the dummy head contains the sorted list, and we need to make sure that there is no right pointers. The right pointers are should be null. So we just made right to null and written a dummy head, so that the list is now only downwards. There is no right pointers. This is it. So once we get it, we can print the list. Here we'll get the dummy head at the finally. So the list will be like this. The total list will be like this. Single direction, all downwards. We cut all the right pointers. Once we merge it, we cut this pointer. Once we merge it, we cut this pointer. Once we merge this, there is no right pointer. So I like this. That's it.